the answer to question 4 on week 2 on the week 2 worksheet. That's the feeling.
Yup. Woohoo! All right. Hello, everybody. Welcome back. We are in week 3 of Intro to Computer Science. This is held at the Trans Academy. I am your second lecturer of the week, Epple. Hello, everyone. All right, let's get started. We have a pretty important concept to talk about today. I feel like I say that every week, but I promise you, this one you may be using more than others. For week 3, we will be discussing loops and conditions. All right, let's get started. Okay, before I move on, just a super quick review of what happened during the last lecture. Last lecture, we talked about some variables, we talked about typing, we gave you an intro to functions, and we also covered a little bit of quirkiness with typing within Python. Now, within the last week's worksheets, hopefully everyone has had a chance to look at them by now or have attempted them. We have tried to provide you some ideas on what it would look like to call certain functions and define certain functions. Today, with loops and conditions, this will power up your code to the next level. Now, with loops and conditions, by the end of this lecture, you should be able to know how to run things many, many times, perhaps even an infinite number of times. On top of that, we will also teach you how to make your program think smarter with conditions. Okay, let's start first with conditions. So, what are conditions? Conditions are the simplest blocks of logic within your code. What this is going to look like within Python is that conditions are going to offer us a multitude of ways to control the flow of our program. When I talk about the flow of our program, what I mean is when you write your program, you can branch the path that the program executes. So under one condition, the program will do one thing. Under another condition, the program will do something else. Now remember that these branches are as infinite as you are willing to make it to be. And this offers us a lot of functionality in how we can control what our program does at what times. So, in essence, it is the logic. This is how we make computers think. Let's take a look at the simplest condition. Now, before I start talking about if and else that you have already seen here, I am going to introduce to everyone a new type. In this week, we will be covering what Booleans are. So, Booleans are a very, very special type in Python. And Booleans make up the very basis of all computer science programs. Under the hood, when you dig far enough, everything comes out to be ones and zeros. And they can be very simply represented with Booleans, true or false. If conditions allow us to perform what we call a Boolean check. A Boolean check basically checks to see if something is true or if something is false. In this case, Python's if statement provides a very, very simple logic on Boolean operation. It is written simply as, if this, then do it, else, do something else. What does this actually mean though? So what happens here is when you write if, you have to provide if and a condition. Conditions can come in multitude of ways, and I'll show you some of what it will look like in the next slide. But if the condition is true, then we will execute the block of code right underneath the if. So in this case, it's do this. However, when the condition is false, we will jump to the else. And in this case, it's do that. A very simple check, but let's take a look at some examples to see how we can properly use it, and then we can have a better, clear idea of how if statements are used. All right, let's take a look at this. Here are some actual Python code. In this Python code, we are simply providing it true. If true, we will print it's true. Otherwise, we'll print it's false. If you run this block of code over and over again, let me ask anyone in the audience, can anyone tell me if they think it's false will ever print? Yes, RI in the middle.
Nope. Because
correct.
true is the Boolean value.
Yes, and answer from RR says false. Sorry, the answer to this question is no. We will never print it's false. And the reason is because of this Boolean value up here. By hard defining a true Boolean value here, it will never evaluate to false because true will never be false. And true is a Boolean value. All right, let's take a look at some more examples. Oh, and does anybody have any questions here before we move on too far? Cool. Let's take a look at how we can perform some Boolean operations. Now, remember what I talked about earlier. If statements require a Boolean comparison. In this case, I'm providing you some examples of Boolean conditions. Let's take a look up top. We have very simple 4 mathematical operations here. They are comparisons. Therefore, instead of setting one to another, we are comparing one to another. And these are the left-hand side comparisons and the right-hand side comparisons. The double equal sign here is the simplest, and you'll see this most often. Double equals in Python represents equals to, or also known as equivalent to. And they're pretty intuitive. It's the left side the same as the right. In this case, 1 and 1 is yes, 1 is equal to 1. The next two, we have less than or greater than. These are fairly intuitive as well. However, for these, we are specifically comparing the values themselves. It's easiest shown using numbers. However, you can do less than comparisons and greater than comparisons on certain objects that are not numbers within Python. So let's take a look at these two examples. Quite simply, we are comparing two numbers together. In the second example, we compare 0.99 to 1. Is 0.99 less than 1? Answer is yes. Sorry, I know some people wanted to answer. I'll give you the opportunity for the next time. But here in this case, 0.99 is less than 1. Python will evaluate that as true. In the third example, 1 greater than 1. Well, let's think about greater than. In Python, there are, when you compare something that is less than or greater than to something else, we have two ways of comparing. The first way of comparing is a strictly greater than or a strictly less than. A strictly greater than or a strictly less than means that it has to be bigger. It cannot be the same. Therefore, in the third example, 1 is greater than 1 will result to false because we are strictly asking for a greater than here. However, you'll notice that in the fourth example, we have an operator that looks very similar to greater than, but not quite. There's an equal sign there. In Python, this means greater than or equal to. So as long as it's within the range that is greater or equal, then this will result to true. And in the same thing, you can also have less than or equal to by simply putting an equal sign after the less than. All right, hopefully everything will make sense here real quick. Let's take a look at another comparison. For this example, we're taking a variable a, and we are setting it to be green. Now, we run a very special comparison here called not equals. Not equals is the exact opposite of equals up here in the first example. Strictly means if the left side is not the same as the right side, we will say it's true. Can anyone here tell me what this statement will evaluate to? A is not equals to red. Let me call on someone else here. Ari Kitty, go for it.
It will be true.
That is correct. The answer is true. And the reason here is because we are strictly looking for a not equals comparison. So with A being set to green in the line above, A is green. Green is not equal to red. This may seem a bit obvious for now, but when we add a lot of these different comparisons together, then things get a little bit more difficult to see. Now, I'm going to introduce you one last comparison before I move on to some other examples. In this case, we have is. Now, is within Python is pretty interesting. No pun intended. The is operator is also a Boolean comparison operator. However, is works somewhat similarly to a double equal sign. Under Python, is compares more with types instead of full values. So the example here is we're looking for if the type of the word cat is of string. In this special case, we would evaluate this one to true. And I'm telling you that because you would think, oh, but why would I use is here? Why can't I just use double equals? The answer is you can, and Python has been more lenient about whether or not you use is, whether or not you use double equals. However, the recommendation here is to keep type comparisons strictly using is, as that is what it's initially made for. All right, let's take a look at some other examples. Yes, question. What is the difference between... Yes. Yes. 1 second, let me turn everyone up a bit. Okay. So the question here is that what is the difference between a single equal sign and a double equal sign? Now, single equal sign we have seen in the lessons in the weeks before. For Python, single equal sign is what we call an assignment operator. And assignment operators work by setting the value on the right to the variable on the left. It's called an assignment operator, and you can think of it by taking the value on the right and pushing it into the left. It's essentially stating A is now this value. When you have double equals, strictly speaking within Python, double equals is a comparison operator. Comparison operators perform Boolean operations and Boolean checks. Basically, the example I have described above, where instead of setting one thing as a specific value, we are now taking two different values, or maybe even the same value, and comparing them together. Hope that makes sense. If you're still confused, feel free to ask more specific questions. I'll try my best to explain. All right, let's take a look at this example. So, in this example, we have something that we have seen last week, which is receiving an input from the user. Now, when receiving the input from the user, what we're happening here is we're asking the user to input an integer, and we're performing a type comparison cast. In this case, we are casting the string that the user inputs into an integer. And we can see here we're using a single equals. The single equals will assign the value that the user has inputted, casting it to an integer, and then setting that into x as our variable. In the next blocks below, what we see here is we are comparing x to many different values back to back. If statements can get a little bit big. Let's real quick break it down. All right, let's look at what's important here. So we can go with the color coding. We notice that there is one if, two of these elifs, and then one else. As we have described in a couple slides ago, the if is fairly simple here. And the else basically will execute whenever the ifs don't match. However, something new that we're seeing here is this middle part, which is elif. In Python, elif stands for else if. What this means is it's an additional comparison that we will attempt to match if the primary if fails. Here's how this code will run. Let's say we run this code and it's asking us to input a number. Someone in the audience, please give me an integer. What is your favorite integer? Yes, Aurora, go.
7.
All right, Aurora has given us 7. So let's see what would happen. We go in here and we would set 7 to x. And thus, we begin to compare. Is 7 less than 0? Well, to be less than 0, you need to be negative. 7 is not negative, therefore it does not match the first comparison. So we will move down to the else ifs and the ifs. Moving down, we see that the first else if comparison is x equals 0. X is equivalent to 0. 7 is not 0. We fail that statement, so we'll move down by one more. Moving down by one more, we will check again. Is 7 equivalent to 1? In this case, it's not. Therefore, we will continue to move down until we either run out of comparisons or we hit an else, or we match a comparison later on. In this case, because we have not matched anything, else becomes our catch-all here. So in the case that every single if statement fails, else will take over and run that code block. So by inputting 7, we will receive more. Does this function flow make sense to everyone? Does anybody here have any questions on what we just ran through? What we did just now is that we tried to step through the code like a computer. Yes, I see a question here. Go for it.
So it was back a couple of slides. It was just a case of when doing the equals to comparison on strings, is it case sensitive?
Are you asking about this?
Yeah, so for instance, if that was a not equal to green, but with green having a lowercase, would it still be true because the green we're comparing it with has an uppercase G?
Yes. So the question here is, when we're comparing strings together, such as A not equal to red, does case matter? The other way of another way of saying it is, if we have a lowercase string and we have an uppercase string, are these the same string? In Python, they are not. And in most programming languages, case sensitivity matters a lot. In fact, in many programming languages, even the case sensitivity of your variable names matter. So a lowercase a may be a completely different variable from uppercase a. Hope that answers your question. Okay, I know we just stepped through this with the 7 example, but let's take a look really quickly at what would happen if we hit one of these ifs. So, anyone got a negative number for me? Any negatives? Aurora, you again. Go.
-7.
Okay. So, -7. Very good. In the case of -7, we head down and we set -7 to x. Comparing if -7 is less than 0, it becomes true. So, now that it has become true, we will now execute the code that is within this block. And after executing this code, we will no longer do any more comparisons within this if statement. Please keep in mind that for if statements, the first and only one comparison condition will run. What I mean by that is, if we hit one of these ifs, or we hit one of these else ifs, that if comparison will end. We will not compare anymore. So the else will only run if all other comparisons fail. In this case, for -7, we will set x back to 0, and we will say we have changed the negative to a 0. Hope that makes sense to everyone. This is a very important thing about if statements. Remember, only one block within your big if statement block will run. If you want to have multiple comparisons no matter what happens, you can write more if statements, one after the other. But if you have if statements and else if statements and else, this is considered one single block. All right. That was comparisons and conditions. We went over a very, very simple worldview of how comparisons work within Python, but not just within Python, within pretty much every other programming language nowadays. We're going to move on to loops. This is another very big concept. Before I move on, I'll give everyone another chance to ask for any questions that they may have about conditions. Cool. And just checking with Rory, anything from Discord or Twitch? Oh, nice. Perfect, perfect. Okay. Let's cover loops. All right. So, first of all, what are loops? Now, in a very simple sense, loops are a way we can make our code run over and over and over and over and over and over again. As many times as you personally set it, or run infinitely until a very special condition is hit. Loops are very important. And the reason why loops are very important is because loops are the fundamental building block behind doing anything over and over again, such as automation, games, etc. Let's take a look at this example. Let's say within this week's worksheet, I have asked you all to print the count is now starting from 0 all the way up to 100. Well, this would be a very tedious task without loops. Maybe this would be what the example would look like. We call count, and then we copy paste it 100 times, and then we go through each and every line and we update the number. Very tedious. I don't think anyone wants to do that. Let's see how we can make this a little bit better using loops. So let me introduce to you a for loop. The for loop is one of the two basic loops that we have available in Python as well as most other languages. Essentially, a for loop provides you the capability to step through a finite set of either numbers or objects, or step through a range of numbers or objects. I know that was a very abstract explanation of what for loops are, but let me show you some examples to describe what I mean. Let's take a look real quick at what the for loop does. In essence, for loops only really do three major things starting from the start. We first perform something and we check to see if we have reached the end of the for loop. If we have not reached the end, then we will do something that you have deemed within the for loop. Then here comes the most important part. We will increment forward. We will move on to the next item. We'll go back and do something again, and we will check to see if it's the last item. If it is the last item, the for loop will end and you're done with the loop. Let's take a look at some code. All right, so up top, we have defined some strings inside of a list. Now, lists are a variable. It's a data type that we have introduced to you during the second week. However, just as a quick refresher, lists can contain multiple of different types. In this case, our list, called words, contains a bunch of words. For this specific example, it contains 3 words: a cat, a window, and defenestrate, which means to throw something out of a window. I'm sure there's some kind of lore here, but let's not delve too deep into that for now. Let's take a look at how we are using a for loop to slowly step through and access these values. Taking a look at the second line, we can see how we are able to define a for loop. In this very specific case, we define the for loop here by saying the word for. And then we provide it a variable name that represents the current item that we're stepping through within the for loop. So in this case, I have used W, that stands for a single word. The in word is a very special keyword within Python that marks this for loop as a for each loop, meaning that we will start from the beginning of words and we will end at the end of words. For every single word, we will perform one operation, and that is to print the word. So let's go back real quick. Oops, I went back too much. Okay, let's go back real quick to this spot and see what happens here. Now, remember, we have a list of 3 words. We'll start with the first item. Is the first word the last item? The answer is no. And therefore, we will do something and move on to the next item. What is this do something? The do something part within this example is the print function. So we reach the first word, which is cat, and then we'll do something with it. So we'll print it out and we'll move on to the next item, which is window. Moving back to the flowchart, we will discover that we will check to see if it's the last item again. It's not the last item yet, so we will move on. We'll print out window. Same thing will happen to defenestrate. Then, once it reaches defenestrate and it does something with it, the for loop will be like, ah, that's the last item. And the for loop will end. There is nothing more here to print. Now, I know I just stepped through the for loop like how a computer would do it, but this is our best way of demonstrating to you what a computer is actually doing with a for loop. Our example here is quite simple. This list only contains 3 words. However, sometimes you will receive data objects that are millions, if not even tens of millions in production or other pieces of code that you might try to write. And in that case, it is strictly impossible for you to, let's say, why don't I just print each word? And these are the powers of the for loop. Does anyone have any questions about for loops? I see someone jumping. Yes.
So what if you wanted it to stop on a certain word? Like if you wanted it to stop on window instead of continuing to end?
Yeah, that's a good question. The question was, what if I wanted to stop in the middle on a certain word and we don't want it to end at the very end? So, I'm gonna get back to you on that because we have an example that's coming up that will show you how we're gonna do this. Oops. I keep hitting the wrong button. All right. So super quickly, I'm going to introduce to you a while loop. A while loop is the second most common loop that you will see out there in the wild. The fundamental difference between a while loop and a for loop is that while loops have one specific end condition, and this condition is set at the very beginning. So a for loop has a strict beginning and a strict end. For loops will step through a certain set of numbers or a certain set of types or a certain set of objects, and it will end at the very end. But that is not true for a while loop. Let me show you an example. Let us take a look at this code. This code is what I like to call a bad password checker. We are essentially asking the user to input a password. And we are saying, while X, in this case, the variable we're using to store the password, is not the word secret, then we will continue to do something. Let's take a look at what that something is. In this case, it's not secret, so we're going to ask the user to input a password. And in the case that it's not secret, then we're going to tell the user, no, you're wrong. This is not the password we're looking for. And this process will continue and continue, looping infinitely until the user inputs secret. So in this example here, we can see that the while loop does not have a definitive end. There is a world out there that this program runs, and whoever is typing on the other end will never type the word secret. And in the case that they never type the word secret, they will sit there forever for the rest of their lives typing out different passwords until they decide to not work with the program anymore. So you'll notice the most important part here in this example is showing you that while statements work kind of like an if statement, except it's got a looping functionality built into it. We are essentially performing a if check here. And if that Boolean check fails, the while loop will continue to run. Hope that makes sense to everyone. If you have any questions, we can step through a little bit with some different examples, and maybe that will help explain. I am going to grab some water super quick. Oh my god, it's kind of nervous to like have this many people watching you drink. Please. It's like miming.
It's all right. You're not. It's not like you're being created at the same time. I'm taking notes.
That's true. All right. So let's take a look real quick at what is a for loop and the difference between for loops and while loops. There are one major difference between for loops and while loops in the way that you will use them. If you already know, or you can find out how many times you will run a certain task in advance. So for example, let's say our password checker in the example before, let's say instead of giving the user infinite attempts, we only give the user 3 attempts. In the case that we only give the user 3 attempts, then we can use a for loop here and tell the for loop to only run 3 times. And I'll show you how to do that later in the Discord. However, if our password checker allows the user to continuously check their password over and over again infinitely, in the case of a while loop, you will use a while loop. So the most important part about the while loop is you're not sure when a certain task is going to end, but you have a specific condition that stops it. So an example here would be video games. When a developer launches their video game or when a user opens up a video game, the developer doesn't know when they're going to close that game. The game will only be closed if the user says exit game or something bad happens and it crashes. Because we don't know, most games have a while loop running behind it. While the game is open, we will continue to do whatever game logic, like VR chat here. And for loops, the example here is that you are stepping through a list of items, which might not be infinite length, and you can kind of figure out how long that could be. So for example, let's say you're writing a video game and you want to look through your inventory to make sure that they have a very specific quest item before they complete a certain mission. In this case, you can use a for loop to go through each one of their inventory and look for that item. Hope that makes sense. Any questions? Oh, and for your question before, let me, unfortunately, we don't have an example of break and continue here inside of our slides. But what I'm gonna do is after class, or maybe Lucia can do it right now, we'll ping you and we'll give you the example of how break and continue can be used. These are a little bit more advanced loop concepts. We may cover them slightly within the worksheet, but for now, we're going to focus on the main topic of loops. So keep an eye out. All right. So, what just happened? In conclusion, within the past, 40 minutes, time flies. We covered the basics of conditions, how you can branch your program to do different things depending on something that you have told it to check. We have also introduced you to loops. How can I perform a very specific set of actions over and over and over again? All right, now we are finally open for some questions. Does anyone have any questions about conditions or loops, or maybe even last week's worksheet, or anything that we have covered throughout this course so far? Rory, checking with you real quick about Discord and Twitch. Perfect. Yes, one question here. Alright, go.
If you want to use a 4 to go from say numbers 2 to 10, how do you write that in Python?
Good question. So the question here is, if we want to use a for loop to go through the numbers 2 specifically to 10, and I'm guessing you want to go through the integers, right? Like 2, 3, 4, 5.
Yes, yes.
Yeah. So in that case, you would be looking for a very specific function within Python called range. Range will generate a list from a number, a starting number, to an ending number. And we can step through it the same way that we did with our previous list. Here. I'll send you an example of what the range operator looks like, but for now, you can imagine that we are replacing words with a range function. And you can simply tell the range function, this is the number I want to start, this is the number I want to end. And everything else will run the same way here within this example. Does that make sense? I'll provide you some code examples in Discord. It's a little bit hard to type here. All right. Or I think if Lucia is there, maybe she can help write out the example as well. Okay. Any other questions? Yes. Question over here.
If you just let like for a game, if you have a while loop and you just kind of let it run, how do you, this might be too advanced, but how do you like control how fast it goes? Because like games have like FPS limiters and stuff. That seems, I don't know how you would do that, I guess.
Okay, this is a little bit of an advanced question. I won't be able to cover it in full detail given the time that we have, but I will attempt to explain it a little bit from a wider lens. The question here is, if you have a while loop within a game, how do you control how fast the game runs? So in games, there are a couple of different ways to control how fast the game runs. If you have a game that is affected by, let's say, physics, gravity, or speed, let's say it's like a ball rolling down a hill, how do you control how fast that ball accelerates and make sure that it's rolling down the hill at the same time, whether somebody is on a 4090 supercomputer or they're using some crappy Toshiba laptop that like lags and like skips frames? The answer here is with time. Most video games track how fast they should increment physics depending on how long it has been since the last frame. So if you think about this in a math sense, if we say that every second the ball moves forward by 1 meter, it's a pretty fast ball. If this is the case, every time the game loop runs, we will calculate the next position of the ball. When calculating the next position of the ball, we will do two things. Number one, we will check the current time. And number two, we will check when was the last frame executed. And by getting the difference of time between these two, we are then able to calculate how far the ball should move. So let's say somebody is running the game at 60 frames per second. So the game refreshes 60 times a second. For them, every single frame, the ball is going to move 1/60th of 1 meter. But if someone is lagging really, really bad, and they have 1 frame per second, then on every game loop that runs 1 second, we will check and see, oh, 1 entire second has passed, and therefore the ball should move forward by 1 entire meter. So within 1 second, the player that has really good frame rate and the player that has really bad frame rate is experiencing physics the same way. Does that make sense?
Yeah, that makes sense.
It's,
Thank you.
yeah, it's a little bit complicated when it comes down to math and game loops, and there are a lot of different optimizations that developers do, but in its essence, games are controlled specifically by time. One of the really funny things that you will see in older games is that older games are locked to a certain frame rate and you can't change it. And a lot of players wonder, why can't I change it? I want to play Skyrim Oblivion on 1000 FPS. Well, in a lot of these older games, the physics engine is actually tied very directly to the frame rate without relation of time. So in some older games, if you look down and you now have more frame rate, you actually run faster, which is a very interesting speedrunning technique. But down in the very basics of computer science, this is why. It's because of loops. Hope that covers it. All right, anyone else? I assume everything from Discord and Twitch are covered, right? That's great. Oh, I see someone typing over here. I saw you typing earlier, Ashley. Did you have a question? Oh, they're typing for a while. Must be a really hard question. I'm getting kind of scared, actually. Okay, the question is, what does exclamation mark equals do? Let's head back real quick. So, exclamation mark equals, this is actually a very good point. In a lot of programming languages, exclamation mark is used as not. Not is a very special Boolean operator. Not signifies the opposite of something. So if you have not true, then it becomes true. Therefore, in many operators that are built into programs or programming languages, the exclamation mark usually marks the negation of something. In this case, exclamation mark equals is the exact opposite of double equals. Double equals is the comparison operator that compares equals. And exclamation mark equals means not equals. So strictly speaking, exclamation mark equals will return true if both sides are different. Hope that answers your question. All right. I am going to give one last round. Going once. Going twice. And sold. All right. Thank you, everyone, for coming to this week's lecture. Oops. Now, just a reminder, we have our workshop happening in about 2 days from now, where you will get some hands-on practice with some questions regarding what we covered today, which are loops and conditionals. Keep in mind that these questions will now have the possibility of containing topics that we have covered in previous weeks. So you may see some functions here and there. You may see some more variable stuff, some more typing stuff. Just keep in mind that. Again, if you have any questions, feel free to reach out to me or Lucia right on Discord. We will be keeping an eye out in the channel. And if you have finished your week 2 worksheets, feel free to submit them. Lucia or I will go through every single submission and we will give you direct feedback. Right, that covers it for today's lesson. Super quick shout out to Moonlit Academy, which will start technically right now. It will be right after this. Thank you so much for coming, everyone. And I will see you all later.